Now it's really time for the Barnard M. Gordon Prize for Innovation in Engineering and Technology Education. It's a kind of prize, it's really the prize recipient lecture. The prize was named in honor of the member Barnard M. Gordon, who is former chair of Neurologica Corporation, and he endowed by a generous gift from his foundation this prize. This award recognizes innovative education modalities in curricular designs, teaching methods, and technology-enabled learning that strengthens students' capabilities and inspires them to become superior engineering leaders. It's a leadership prize. The $500,000 prize is shared equally by the recipients and by the universities to support continued development of their award-winning program. In January of this year, the NAE awarded the 12th Gordon Prize to Northeastern University educators Simon Pitts and Michael Silovich for developing an innovative method to provide graduate engineers with the necessary personal skills to become effective engineering leaders. Northeastern University's Engineering Leadership Program is a graduate degree and certificate program focused solely on developing leadership skills for practicing engineers. This GEL curriculum has 5 core pillars: leadership capabilities, leadership labs, product development, scientific foundations, and a challenge project. Typically, the GEL student has 3 to 5 years worth of experience in the field prior to entering the program. The mode brings together teams of students who gain common understanding of how to tackle challenges through rich discussions and mutual learning. Mr. Pitts and Dr. Silovich have played really critical roles in establishing the program and also ensuring that it continues to produce well-rounded engineering leaders who will solve our world's grand challenges. They are both here today, and I ask Mr. Pitts to come to the podium and present the Gordon Prize lecture, after which we'll have time for questions. So please come forward now to present this lecture. Great. Michael, the floor is yours. Great.
Thank you, Dan. I'm delighted to present this lecture today on behalf of Northeastern University, Michael, and I'd also reference Professors Klosterman and McGonigal, who have been instrumental in inventing and implementing this program. Northeastern University is a hallmark of experiential learning, and we use experiential learning very significantly in the program, as I'll share with you in a moment. So Northeastern, as many of you may know, started experiential learning in about 1909 in its undergraduate program, where 3 6-month periods of work in industry are included into the curriculum. So the additional benefit of context of industry is absolutely key to enriching the education that the students get. Some people think Boston's a very cold, snowy place. We only got 108.6 inches this year, but the rest of the season's very good, and the snow farms have all melted now, so we're well prepared for next year. The program concentrates on the knowledge, skills, and very importantly, the attitudes at the intersection of engineering and leadership. So this could be the 2 sentences. This is the first sentence. The second sentence is, we're teaching how to lead people and how to lead complex technical programs and processes. Before I go into describing the program to you, I'd just like to share the motivation and why we're so passionate about why engineering leadership is important to the country. If we look at US competitiveness, the chart on the left-hand side, the blue curve that you can see at the top is high-tech products. The orange curve is all manufactured products. On the vertical axis, the second number down is 0. That's the the balance point of the trade, and we're going across the lower axis from 1990 to date. And I think we're all familiar with the fact that outsourcing and globalization have driven a very negative balance of trade on manufactured products. But the really worrying sign is that since 2001, the balance on high-tech products has gone negative and showing no trend of reversing yet. Now, why is that a metric we should worry about? Historically, about 2/3 of the US's R&D is undertaken by manufacturing companies. And while the US is a leader in manufacturing from 1895 to 2009, when China took over, this is really key to reverse. And engineers who lead teams effectively can get very, very significant improvements of output. So while we can argue of the number of startups that fail, the number of years it takes for them to fail rather than to succeed and to scale up, or while we can argue about mature companies that need to respond to disruptive technology, changing business models, I think we can all agree that great engineering leaders and teams of engineers are part of that solution. If we look at the current state, in a former life in Ford Motor Company, when I hired engineers, I found early career engineers were missing a number of things that were needed to be able to participate in and then lead teams. And the companies that we partner with at the moment, some of them report that the first time yield on a young engineer leading a team is about an 80% failure rate. We educate our engineers very, very well in the fundamentals, but there are huge gaps to the skill sets that they need to be able to participate well in the teams and then lead the teams. Here, I'd like to go through three groups, the first one being implementation skills. So leading teams, it's critical to optimize performance, quality, cost, and timing. And typically a young engineer will come in and start trading them off. Would you like quality or would you like cost? Well, actually the customer demands both. Front loading, key with a program is exploring the design space, understanding the constraints. When it's free, there are no real costs to changing your mind or changing the concept. Young engineers tend to come in and start designing. They've probably sunk half of the engineering budget and starting to commit a whole load of the tooling budget before they realize what they've done. Engineering for the real environment, the self-defining the degree of rigor required, and designing for manufacture and designing in quality and robustness are skills that they haven't learned. If we look at interpersonal skills, leadership and critically followership, being able to follow the leader of a team, it's not coming naturally to what is typically an introverted engineer with very poor communication skills. Team skills, interdisciplinary skills, connecting across cultures, and indeed the willingness to engage. These are gaps that these engineers have coming in. And the final category is breadth of focus. We teach very, very narrow disciplines. So they come into companies with that narrow focus. They don't have a feel for stakeholder needs, market positioning, market needs, and customer needs. They don't understand the enterprise or indeed the extended enterprise, and they really don't have enough business acumen to have business drive their engineering solutions. That generates our mission statement. How do we close the gaps? What does success look like? So our mission is to create an elite cadre of engineering leaders who stand out from their peers in their ability to innovate, important, invent, important, and implement, exceptionally important, engineering products from concept to market success. And they've got They have to demonstrate exceptional ability to provide purpose, direction, and motivation to influence others to achieve their collective goals. Not quite 2 sentences, but I can work on it. This is the graphic that I'd like to take you through. This is the program on one page, if you like. And Dan mentioned the 5 pillars: leadership capabilities, leadership labs, product development process, scientific foundations, and the challenge project. Before I go through the details of each of those 5 pillars, I just lay through the timeline for you. Students come and join us in the fall each year. They take leadership classes, leadership labs, they do product development classes and scientific foundations of engineering through the fall and the spring semester. At the end of the fall semester, the challenge project starts to ramp up and it runs through the spring and the summer. In year 2, the vast majority of the students, more than 90%, continue in the discipline of their choice to get a master's degree. So if we look at the foundational elements of the program, engineering leadership seminars. We bring in once a week a different engineering leader from a different industry to share their leadership journey, how they learned to lead, what they think is important, and we effectively give the students alternative role models to pick from, to contrast from, and to discuss the topic. Because the cohort are constructed from a number of different industries, they become an amazing resource to themselves in cross-industry benchmarking, and they actually set themselves up as a network for the rest of their careers. 2 other elements in the foundation are experiential learning and 3-way mentoring. So experiential learning, the 2 key parts that are featured in our program are the leadership laboratories, which I'll take you through, where immediately after a class there is practice to get mastery, and the challenge project itself, where they're delivering everything they've learned in the program in the context of a real company and a real solution. The 3-way mentoring, because we have different criteria for the project's success, we have a mentor from the program who's looking at the learning objectives. We have a mentor from industry who's looking at the project objectives in terms of impact. And we have a faculty advisor who's expert in the technical field to advise the project. So let's start with leadership capabilities. By coincidence, we have 14. The leadership capabilities we show on a polar plot. The reason we do this is when the students join us initially, we get them to self-assess their leadership capabilities, and I'll describe each capability in a little moment. But they self-assess so that they can see their strengths and weaknesses. They then produce their learning plan with their mentor to build on those strengths and to close the gap on the weaknesses to produce a rounded engineer. At the end of the program, we then get them to self-assess again, and we turn it into a 360 by getting their boss and their peers to rate them also. If you look at the leadership capabilities, if you start at the top with initiative, which is fairly clear, decision-making, responsibility, urgency to deliver, ethics, trust, courage, vision, all fairly clear. Early career engineers almost always fail to have the ability to lead a team, to inspire a team to produce a level of fidelity of product, be it function, be it quality, be it reliability. They can't even articulate the vision, let alone motivate the team to deliver it. We can help that, and we do. Realizing the vision, how to take that vision and put it into success in the marketplace. And then as we continue through inquiry, interpersonal skills, communication and advocacy, connecting across disciplines, across cultures, and negotiating and compromise, these, and I shudder to use the word, these are known as the soft skills, which means people don't prioritize them. These are the really vital skills to effectively lead a team. We have a split distribution on negotiation, for example. Most of the early career engineers will negotiate very, very poorly on price, on function, on anything. The other distribution will go to the ends of the earth to get what they want, with somebody that they have to partner with for the next 10 projects. So they completely kill the relationship trying to over-negotiate one particular area. The next area is leadership laboratories. So when we've taught a leadership class, we then get them to practice to mastery. When the group first come into the program, we have something called a field leadership reaction course, which is a fairly aggressive version of a leadership lab. We bring them in, give them a Myers-Briggs MBTI analysis so they can understand themselves and how different they are from their team members. And then we give them a fairly intensive but not really life-threatening series of tasks at an army base in Cape Cod. So this is a couple of images at the early phase of the program where they're going through a planning, they're looking at the material they've got, they're understanding the challenge, what they've got to do, which is typically getting the whole team and some cargo across an obstacle. The first time they do this, typically they don't spend very long planning, and they spend a lot of time replanning, and they typically fail. This is an example where the team and the cargo have to come over a very high wall at the back and come forward across some chains. Here's another example where they have to get the team and lumber and cargo, and the lumber is strategically short. It's then over these two pillars across the water and to dry land. After each test, we have an after-action review with the ROTC members, really giving some detailed feedback on what went well, what didn't go well, and why. Some of our students are initially very resistive to this, and they soon see so much value that they get on board with the process and they use it themselves regularly. On the left-hand side, you can see we also do a team debrief, and most of the team members are dry, but not all. And on the right-hand side, there's some student feedback, which I'll read for you. This was perhaps the best leadership and team-building experience I ever had. It was a unique opportunity to see a team form and develop before my eyes as we learned individual team members' strengths and weaknesses. At each obstacle, we determined which team member would be best at solving various solutions and complex challenges to get the whole team across the finish line. So you can say, why on earth do you take them to an army base? We're trying to get them to realize this message in every engineering job that they do. In the classroom, we do the same thing. For every time we have a leadership lesson, we give them an after-action review in a simulated real-world environment. It might be role-playing, it could be case studies, but it's the same experiential learning. Next, we teach product development. So an end-to-end process to characterize all the way from the customer to the product. We take them through some generic product development processes, waterfall. We take them through agile, scrum, spiral development type processes, explain why they exist, why it's cross-functional, where the interdependencies are and are not. Then we send them back into their companies to understand how their companies say they do product development and actually do product development, which tends to be somewhat different. We then bring them back, and one of the most meaningful discussions you can have is someone from a 5-person startup discussing somebody from Lockheed Martin or Raytheon or Boston Scientific, why it is that their processes look so different, but in fact, the logic and the drivers are all identical. So they start to understand how to customize to their application. Candidates learn to really translate customer needs into technical specifications and business specifications. to not only design, but to design the test plan to validate not only the virtual world, the virtual prototypes, the prototypes, and then the production tool product that behaves completely differently. And effectively lead teams in not only the enterprise, but the extended enterprise, where sometimes we need to go from raw materials through suppliers into the company, all the way through the company outside the other end to the distribution system. The next pillar is scientific foundations, and this is really a framework for technically leading people in different disciplines than your primary skill set. This supports the T-shaped model, where you have depth in one discipline or depth in one system, and then you have boundary crossing capabilities to be able to lead across the whole system. The rest of the program concentrates on a lot of boundary crossing capabilities. The Scientific Foundations course very specifically concentrates on technical cross-boundary leadership, basically understanding and getting a common language by going to the first principles of each of the disciplines. It also has a secondary effect of strengthening their ability to go deep with scientific analysis when they hit problems and when they're at critical stages of the design. Finally, the challenge project. For the sponsoring company, this is a product of value. For the student, this is the ability to put everything they've learned into the context, the real-world context, where logic doesn't necessarily reign supreme, where things happen, things change, priorities change, budgets change. So it's really a win-win. The three main areas that we focus on in the Challenge Project, it's project-based learning on market value, technology development and technical depth, and leadership. The scope of each of the projects is set deliberately above the capability of each of the candidates to stretch them to really learn. And the image on the left is two of our graduated fellows who were in a firm called Integris. Integris supply manufacturing support equipment to a number of industries. Bo and Dan's projects were both in the silicon side of the wafer business, one doing micro testing and the other doing CMP polishing technology. Both of their projects produced very significant time to market advantages for Integris. Here's a sample of students and companies to give you a flavor. We have EMC, Raytheon, the FDA, NEC Energy, Entergy, Pilgrim Nuclear Power Station, and Mitsubishi Heavy Industries. So the projects really range very broadly to fit the industry, to fit the challenge brought by the employer. I'll just go through 4 vignettes to give you a bit more color. Trevor Ruggiero worked for a company called Fisk, very small engineering company based in Boston. And his project was to do some very fundamental analysis on a disruptive HVAC technology. And the success of his project was that not only did he complete it, he brought that completed project to the VC firm that invested in the next phase of the company that was the customer. Since then, 3M have also invested, and they're moving along chasing a significant business. In the US, it's about $250 billion. Artisan industries, they make process equipment for petrochemical, food, and other industries. So Sky Young's project was to introduce a new separation technology using basically ceramic filtration. And the noticeable thing on her leadership development was not only when she found that the supplier of the ceramics didn't understand the real strength at high pressure and high temperatures, when the system failed, the way she shut down the pilot plant, evacuated the customers and the rest of the people, is now the benchmark process for her company. Neurologica, which is a startup company that Bernie Gordon co-founded after he'd retired from his original company because of he was too old to serve on the board, I think was the rumor. But he's relentless. Matt Dickman, his project was to develop a way of holding the head. The initial product was a brain scanner. So this is a CAT scanner or CT scanner that moves along so you can take the scanner to the patient, which is really critical with head injuries because the mortality speed is so fast. So Matt's challenge was to find better ways of holding the head during neurosurgery and during scanning. He has no medical training, and yet he built such a good relationship with the customer, and the customer is the neurosurgeon, that he's been with the customer in the OR in, so far, I think, about 6 different countries. So he delivered the product, which is patented and in the market, but the real quality that Matt showed was his ability to work with customers to viscerally understand what they needed. They couldn't articulate what they needed, but with him being in the theater with them or in the OR with them, he really developed the solution. And finally, Harry Markasian of Bose. Bose, I assume, needs no introduction. Bose had a very intransigent manufacturing problem with a very hot-selling new product. And the significant impact of Harry's project, which was a significant team of material scientists, industrial engineers, researchers, and product development engineers, he saved that product line many millions of dollars over a short period of time. But his real impact to Bose was he went back and did a prevent reoccurrence, and they now have a process that's looking at optimizing the manufacturing before the technology leaves the research area. And that is incredibly valuable to them. So our final area is everything we do has market, customer, and stakeholder focus. As I mentioned, the program is modular. You either take a 12-month certificate, or you can take a professional master's of science, or a traditional master's of science, or a PhD integrated with the program in any of the disciplines that we offer in the College of Engineering. We're somewhat proud of the results of the program. We have our industry partners advising us that our graduates have much more of a holistic view of the business that they're operating in. They're able to run teams significantly more successfully. Our promotion rate 12 months after the program typically is around 50%. If you move that out to the 2-year point, it's about 75%. This is some feedback from an NAE survey that was done July 2014. So the first question was, how would you rate the program in contributing to your overall character and leadership development? So 90% came back that it was the most important experience yet or essential to development. And the remaining 10 said it was important but not essential. And in terms of the extent to which the program contributed to your advancement, 68% said not likely without GEL or it had been a major impact, and of the remainder, 27% said it was important but not essential. And yes, there is a rounding error if you try and add it up to 100. So, nearing conclusion, the leadership program that we've developed delivers on its mission. It improves the ability to lead very diverse teams of engineers and non-engineers, and it improves the capability to lead complex process and product problems. So we're closing the gaps, we're building on the foundation that the engineers had in the first place, and we're accelerating the contribution and their careers. And that's coming back right to the beginning of US competitiveness. And finally, I'd like to thank Dan and the NAE and Bernie for coming to Northeastern in April for the award event. Thank you very much. Yes, absolutely.
I'm supposed to moderate them or something to that effect. I'm not sure exactly why. Simon Pitts is open for questions you have about this program. You notice that it's a program that really focuses on graduate engineers. That is, people who already graduated and have experience in engineering, and they're brought back to this program. Focuses very sharply on this leadership training. He created the program. They've made it go. Both he and Michael are really the cornerstones of this program for a long period of time. It's been evaluated by industry and by the graduates altogether. And so if you have any questions, this would be a good time to raise them. There's probably a microphone, I presume, that'll race around to find you. Yes. The question is basically what other universities or colleges are following the lead of Northeastern University on this?
The answer is we have a growing number of schools, MIT, Penn State, University of Toronto, to name just a few. We have a community of practice with 15 schools. We're also growing a leadership division, leadership education division in ASEE. We went from a constituent committee last year to a division this year where we have about 250 members. So we're busy growing.
Sorry, I look invisible, right? So a couple questions. How do you select people? It must be rather small. So what are the numbers that actually participate in I guess, an annual group? And how do you select them? And one thing that really I wonder, they can't all be leaders. You showed us some leaders, and they were very impressive. In fact, the whole presentation was impressive, I should say. But who are the ones that are in the team, but they're not the leaders?
So we select through a growing nucleus of companies, and we select through people that are hearing about us through word of mouth marketing on campus and off campus. Our selection process is somewhat rigorous to make sure that we can upskill and give the students the right benefit. There are some students where we feel we could not help them, and we agree not to start the process. But we have found so far that our success rate of the people we accept, we can increase their capability very markedly. Some come in at a much lower level than others and leave at a significantly higher level. They're not all superstars, but this technique accelerates everybody's potential.
And so how many are you bringing in each year? And then I'll let you go.
We started small. We started in the sort of 10, 15s. We're currently bringing in 40 per year, heading for 50.
Yeah. Very impressive program. I'm interested in a similar question about scaling and how all engineers need these leadership skills, I would argue, either because they have to play on a team or they'll ultimately be asked to lead a team of some sort. And I'm wondering if you have any thoughts on how you scale this to the large number of undergraduates that exist in all of our engineering programs.
Excellent question. We have a small undergraduate feeder program that we're experimenting with, and we find that the opportunity is huge. And I mentioned the community of practice. One of the members is University of Florida, who are trying to do this at very significant scale. So part of the community of practice is developing the techniques and developing the scale potential.
Thank you for a wonderful presentation. Could you tell us a little bit about how much you train or emphasize the idea of communicating their successes, both within the industrial or engineering environment, as well as an academic and publishing environment? I think their successes need to be communicated to be most effective. How do you train them in that?
That's an outstanding question. Most of our current performance has been sharing within the industry and within their companies. What we haven't done enough of yet is to publish, and that's one of the reasons why we're building the ASEE Leadership Division, so that we can really spread the word in the academic community.
And do you train them in making videos, doing social media? How else do you give them the experience of communicating their ideas to broader publics as well as professionals?
That's an area that we haven't got into yet, and it's very fertile ground.
One question. Simon, is there essentially a cadre of universities that are sort of working together? You described it sounded like there's a sort of team of universities that are sort of moving in this direction together in some way. Is
That's correct. That's the community of practice called Complete, which is, and in fact you were kind enough to visit at Rice, which is one of the other schools. So we're building slowly and carefully. But I think that, to the prior question, we've got an inflection point where we can really leverage the message.
I see. Thank you very much, really. Very nice.
Thank you.
Very nice. Thank you very much, Simon and Michael, both, for bringing us this program, and one you've worked so hard on, and has actually gone quite far in terms of demonstrating its success rates.